So the objectives of this experiment is to learn about 8051 timers, timer modes, and using timers in different timer modes, and what are the registers associated with timers. Using timers to get a calculated delay. So there are two ways to use the delay. One way to make a delay is by making the for loop. For example, the normal for x equals 0, x less than 10,000, x plus plus. Now, the timers, before we use it, we need to understand. So in our theory class, I have told you that there are two timers, and the timers are called timer 0 and timer 1. Now, the size of the timer of 8051 is 16 bits. Okay, and we can control this, we can set, we can read, we can configure. And there are two functions of the timers. One is to keep the time, or to calculating the amount of time between the events, and another one is by counting the events. So that's why number 1 as a timer and number 2 as a counter. Okay, but it's still called timers, but timers has two functions. It can be timer, it can also be a counter. Now question, how does a timer count? So the timer will count always going up, or it will be counting up. Let's say it starts with 0, the next will be 1, the next will be 2, 3, and so on. Okay? And again, it can be a timer or it can be a counter, but it does not matter. Whether it's a counter or a timer, it's still counting up, not counting down. And it is always incremented by the microcontroller. When you say incremented, it means increase by 1 or increasing. That's the meaning of incremented. Now, there are what we call as special function, because it has a special function or a special use, registers. And the timers will be using the following. Okay? So the first one, we can use the T mode. Remember in theory, this is called the timer mode, and it controls the operation. Okay, whether we will use timer 0 or timer 1, counter 0 or counter 1. And it is also used to set the mode. Do you remember how many modes we have yesterday in theory? 0, 1, 2, and 3. Now, we also have what we call as T-con. This is timer control. And this controls the running and stopping and the flags of the timer. Next, we have THO and TLO. Remember yesterday? High byte or higher byte. And this is actually 8 bits. And the lower byte, which is actually also 8 bits. So, we can have TH0, TL0 for timer 0. And we can have TH1, TL0 for timer number 1. So the timer 0 and the timer 1 both have 16 bits, but the 16 bits divided to 2. And the 8 bits for the TH and the 8 bits for the TL. And we put 0 so that we know it's timer 0. We put 1 so that we know it's timer 1. So if I say timer 1, it means we will be using TH1 and TL1. If I say timer 0, later we will calculate the value that we will put in the TH and the TL, okay, in the program. Now, each timer can be used in 4 modes. As I have said, we have mode 0, mode 1, mode 2, and mode 3. And mode 0, 13 bits. Mode 1, 16 bits. And mode 2, 8 bits. And this one is split mode. So you can use both the timers at the same time. Now, the mode 0, if you calculate 2 to the power of 13, it will be 8192. Mode 1, 2 to the power of 16, that will be 65536. This is important in the calculation. Okay? Because there's a formula which is 2 to the power of n. So, we can use 2 to the 13, 2 to the 8, or 2 to the 16. It depends what mode you are using. Now, in our laboratory, we will just use two modes. Mode 0, mode 1, but we can also use mode 2. And I will explain to you what's the difference if we do that. Now, in the next slide, let's have what is mode 0 really. So, when you say mode 0, what's the size? 13 bits. When you say mode 1, what's the size? 16 bits. Okay? And mode 0, this is the old mode that we are using. And it is because there's an older 8051, which is 8048. So that it will be compatible. Understand? For example, you have a new mobile phone. So the new mobile phone has a new system, operating system. You have a new computer, you have a new Windows operating system. If you have a 10-year-old computer, maybe the application that you want to install in the old computer will not be working. You understand? So that's what we mean by not compatible. Do you understand the word compatible? It means it can be, the old can be used with the new. So if you have a new system and you have a new application, you cannot, like you try, in your old mobile, sometimes it will say, I'm sorry, you cannot install this. The system does not accept. It's not compatible, right, with the version. So that's the meaning of compatible. Now, mode 0 is actually 13 bits, but we are still using because they are saying that it's so that it will still be compatible with the old model of microcontroller, which is 8041. So, but generally, we don't use it in the new developments. Now, the TL0, okay, or TL1, all right, will count from 0 to 31. And when TLX is incremented from 31, what will happen? It will reset to 0 and increment THX. When it goes back to 0, it will also add 1 to the THX. So that's the rule in mode 0. And not, remember, the timer has 16 bits, right? Correct? But we will only use 13. 13 bits for mode 0. Okay? We will use only 13 bits. And we have here, we will use bits 0 to 4 of TLX, and we will use bits 0 to 7 of THX. So 0 to 4, that's 5 bits. It's supposed to be 0 to 7, right? Because TL low byte is 8 bits. TH 8 bits. 0 to 7 TL. 0 to 7 TH, but we will only use 0 to 4. So we will use 5 of TLX. So 0 to 4, 0 to 5, 5, 6, and 7 we will not use. And then for TH, we will only use 0 to 7. Full. We will use THX fully. Okay, but TL only 0 to 4. The other bits 3 will not be used. So if you add 5 plus 8, how many? 13. For mode number 1, 16-bit also. This is commonly used. This is what we usually use. Up to 65536. The other one, mode 0, only up to 8192. This is important to know. And the TLX this time will be from 0 to 255. See that? So it will count from 0 to 255. Remember, 255 is like FF. 1111, 1111. So if you will think, the timer will count from 0000, 0000. Okay? And the last number will be 1111, 1111. You understand that? But to make it more easy to understand, let's make it decimal, 0 to 255. And when it reaches 255, what will it do? It will be what we call rollover. Rollover means go back to 0. Okay? And this will, when it goes back to 0, then the TH will be added with 1. So what happens? TL will count from 0 to 255. After reaching 255, it will go back to 0. And then, after going back to 0, TH will be added with 1. Again, it will count from 0 to 255, go back to 0, again, add 1 to TH. You understand the idea? Mode 0, it will count from 0 to 31. From 31, roll over to 0, add 1 to TH. Therefore, you can now explain what's the difference between mode 0 and mode 1. Okay? Now, not only mode 0, mode 1, what's the other two? Mode 2, mode 3. So, for mode 2 and mode 3, let's see. Mode 2, this is called auto-reload mode. Mode 2. Which mode has 13 bits? Mode 0. Which mode has 16 bits? Which mode counts from 0 to 31? Which mode counts from 0 to 255 for the TL? Mode 1. When it reaches the last number, what do we call it? When it goes back to 0, we call it rollover. And what will happen to TH? Add 1. THX holds the reload value. When you say reload, load again. That's the meaning of reload. You understand? Reload. So, reload is in the THX. Okay? Whatever we want to reload, it's in the THX. And TLX is the timer. Huh? Clear? Next. The TLX will start counting up. When it reaches 255, it's the same with mode 1. Huh? Because mode 1 also counting up to 255. What happens? If you add one more to 255, it should roll over to 0, right?
Yes, sir.
Yes. But what happens? It will not reset to 0. Like mode 0 and mode 1. What will happen? It will go back not to 0, but to the value that you put in THX. You understand? So if I put AA in THX, you understand what's happening? The TL will count up to 255. It will go back to 0? No. It will go back to the value in TH. You understand? Why teacher is not going back to 0? It should go back. No, the rule here in mode 2, it will go back to the number that you assign in TH. Again, for those who are late, the timer has two parts, TH and TL. Timer 0, 2 parts. TH0, TL0. TL will count up to 255. When it reaches 255, it will go back to 0? No. It will go back to the value of TH. For example, the TH0 has FD. FD. Is that 0? No. When TLO holds the value FEH. Okay? FEH. And then, if we were to watch TH0 and TLEO, let's see what will happen. In the first machine cycle, the THO is FD. Okay. The THO is now TLO is, let's say TLO is FE. FEH. Okay? And what's this? Sorry, the decimal. Let's make it decimal. The THO is 253. Okay? And the TLO is already 254. What's next to 254? 255. What's next to 255? In mode 0 and mode 1, it should be 0. But look what happened. It goes back to 0? No. It goes back to 253. Is it correct? No, it should be 0, right? But remember, this is mode 2. And then after 253, 254. Or let's say I did not put 253 in the THO. I put in THO 03. 03. After 255, what's next after 255? Is it 253? No, 03. So we can control the counting. In mode 2, we can control the counting. Mode 0, 0 to 31. 31 to 0. Mode 1, 0 to 255. 255 to 0. But mode 2, no. 0 to, let's say it starts from 0. Although I think it will not start from 0. It should start from TH. But let's say it starts from 0 to 255. 255 to 0, no. 255 to 03. You understand? So if we want it to only have five numbers, it will be 255, 254, 253, 252, 251. Okay. We can put 251 to the TH0 so that when you reach 255, it will go back to 251. You understand? Oh, that's mode 2. Okay? Next, THO will never change, of course, because THO is like the limit. Huh? And when you use mode 2, you always say THX, you always set or you always put a value to the THX. You will see that when you see some example programs in theory, but we don't have yet. Huh? Now, TLX is the special function register that will always be incremented. What is a register? A register is like a temporary storage, okay, of data or address or a value, temporary. And it's 8 bits. That's a register. Huh? That's what we call register. So what's the benefit of this? So the benefit, for example, if you only want the counter to have 200 to 255, what will we do? We will put 200 to THO and we will put 250. We will not do anything with 255. So the counter we start the timer. We start running the timer. How to start running the timer? TR0 equals 1. TR0 equals 1 to start the timer. If I want timer 1 to run, I will say timer 1 run. No. You will write TR1 equals 1. Huh? You get the idea? Now, if you're using assembly language, set B TR1. That's in assembly language. When you use mode 2, what else? When we use mode 2, the when you use mode 2, the microcontroller will take care of this for you. No need to worry about the rolling over. Once you have configured the timer in mode 2, you don't have to worry about checking if the timer has overflowed or what do you call that, roll over. No need to worry because or resetting the value because the microcontroller will do it for you. Now the last mode, mode 3, what is this? The timer becomes two separate 8 bits timers. What is the real size of the timer? What's the size? 16 bits, right? But this time, timer 0 will be like 8 bits and timer 1 will be like 8 bits. How? Example, we want to use timer 0. But timer 0, we will use mode 3, split mode. Huh? So, TLO of timer 0 will become the timer 0. And TH0 of timer 0 will become timer 1. So, that's not the real timer 1. Huh? Look, listen to me, look at me. This is timer 0, 16 bits. This is timer 1, 16 bits. You understand? But now what we are saying, timer 0 will be like timer 0, 8 bits, and timer 1, 8 bits. But where is the real timer 1? The real timer 1 is here, 16 bits. So this 8 bits of timer 0 will be said, 8 bits of timer 0, you will be the timer 1, huh? But I'm not the real timer 1. I know, but what we will do, we will use timer 0 in split mode. So we will ignore the timer 1 and we will have timer 0 with I don't know how to say. Timer 0 will have timer 0 and timer 1 inside. You understand? So there's what we call real timer 1. Huh? Okay? But this is timer 0. Huh? Imagine timer 0 will have timer 0 and timer 1. And then the real timer 1 is here. You understand what? Okay. Now, both the timers will count from 0 to 255. All right? And when it reaches 255, what will happen? Overflow to 0. Huh? Understood? Timer 0 and timer 1 will count from 0 to 255 and it will overflow to back to 0. Clear? Same as mode 0 and mode 1. Now, while the timer 0 is in split mode, here, look at this. The real timer 1, listen listen, look at me. This is timer 0. It has timer 0 and the fake timer 1. But the real timer 1 is here. It has TL and it also has TH. We call it TL1. I mean, if you don't listen, you will not understand. But I hope you do. Now, what we are saying, the real timer 1, which has TH1 and TL1, can be in mode 0, mode 1, or mode 2. So what will happen? Listen to me. Listen to me. How many modes we have? 4, right? 0, 1, 2, 3. Correct? What we did, timer 0, we make it mode 3, split mode. But the real timer 1 can be mode 0, mode 1, and mode 2. So in other words, we can use 2 different modes now. Timer 0 can be used in split mode, mode 3, while timer 1 can be used as mode 0, mode 1, or mode 2. That's what we are saying here. Understand? So that when I ask you, for example, differentiate, what will you differentiate? Mode 0, mode 1, mode 2, and mode 3. Important. You can tell about the short meaning. 13-bit, 16-bit, 8-bit, and split mode, correct? The first one, mode 0, 0 to 31, roll over to 0, add 1 to TH. The second one, mode 1, 0 to 255, roll over to 0, add 1 to TH. The third one, mode 2, from 0 to 255 also. 0 to 255, but there will be a TH number. So we can say from TH to TL. And then the last, what I'm talking about, we have timer 0 will be having timer 0 and another timer 1, and the real timer 1 can be in mode 0, mode 1, and mode. That's enough, I think. Now, however, yes.
Mode 0, count from 0 to 31, right?
31, yes.
But mode 3, how it count from 0 to 255?
What is 255? FF, right? Oh, what is FF? 1111, 111, 8 bits, right? Also, timer 0 has TL, which will be timer 0, that's 8 bits. Also, timer 1, which is TH of the timer 0, will be also, you understand each other? Okay, so however, look, however, you cannot start or stop the real timer 1, How to start or stop the real timer 1? How? The timer 1. TR1 equals 1, it will start. TR1 equals 0, it will stop. The timer, we cannot do that. Because the bits that do that are now, the owner is the timer 0. The TH0, this is timer 0. This is difficult, but this is timer 0. Timer 0 has TL and TH. The TL0 will be timer 0 and the TH0 will be timer 1. So the timer 1, the real timer 1 cannot start or stop because it already gives its right to the timer 0 who is now controlling the fake timer 1. So we can start the timer 1 of by running the timer 0. How to start the timer 0? TR, the R means run. Timer run, TR0 equals 1. What's the meaning of TR1? TR1 means it's used to stop or to start the timer. What's the use of TH? TH means high byte. The timer has 16 bits. The higher 8 bits is the TH. The lower 8 bits is the TL. You understand? What's T mode? T mode. T mode means timer mode. You can put what timer you want to use and what's the mode. Okay? Clear? Remember yesterday? T mode. All right. Now, the real timer 1 in this case will be incremented every month. So in other words, when you start running the timers, whether you like it or not, it will also increase from 0, 1, 2, 3. It will still count. Okay, together with the whole system. So that's it. But what's important here, take note, you write it down. You should be able to differentiate the 4. How do we calculate? This is the formula to calculate for to calculate for the initial value. Okay? Now, you may ask, teacher, what is initial value? This is the number that you will put to the, like here, look at this, see? TH0 will be 4B hexa and TL0 will be FD hexa. What is that? That is if we want to have a delay of 50 milliseconds. In other words, the timer, it can give us the exact time. In the labs that we are doing, how do we make a delay? For x equals 0, x less than 10,000, x plus plus, correct? Here. But in the theory, we don't use 10,000. In multisim, if I use 10,000, it's very long time. In other words, it depends on the system you're using, and this is not exactly 1 second also. We just assume that 10,000 is 1 second, correct? Now, what if I tell you, calculate 1 second exactly? That's the question. But let's start with a small number. By the way, what do you mean by 1 second? How much is it in milliseconds? 1,000. Are you listening? 1,000 milliseconds, that's 1 second, okay? But let's start calculating from 50 milliseconds. Huh? Are you okay? We will not calculate 1,000. We will calculate first. In your lab task 1, you need 1 second. We will calculate 50 milliseconds. What is 50 milliseconds? In seconds, it's like 0.05. Am I correct? 50 milliseconds. If you want to make it second, 0.05. Correct? 50 milliseconds is 0.05 second. Correct? Yes? Or what is 500 milliseconds? That's 0.5 second. Now, but there's a reason why I want you to learn 50 milliseconds. I will tell you. It will make your life easy later. Huh? But let's start the 50 milliseconds. Again, what are we doing? Maybe you don't understand. In our program, there is what we call TL and TH. Understand? We need to put a hexa number to TL or TH. For example, I told you to use timer 1. It means you will have TH1 and TL1. Can you follow? If I ask you to have timer 0, it means you will have TL0 and TL1. Is it clear? Timer 0, TL0 and TH0. Okay? You always think like that. For example, in the question, it says, use timer 0. Oh. In your program, you will have TL0 and TH0. What will you put in that number? What number will you put there? 0x what? What 0x will you put?
0.
It depends on the calculation. Okay? So, let's see the calculation. Look, the calculation here is 2 to the power of n. Okay. What is n? The number of bits. Let's say I want mode 0. So if I want mode 0, what's the number? 13. If I want mode 1, 16. If I want mode 2, 8. Okay? So, these 3, but I will just give you mode 0 or mode 1. Huh? Now look, 2 to the 16, you see that? Minus 1. So that will be 65,536 minus 1. That will be 65,535. Clear? Is it clear? Clear? Mode 1, huh? Mode 1. Okay. What's the delay? 50 milliseconds. Now, remember, in theory, I told you the crystal frequency will be divided to a certain machine clock cycle. For example, if you're using ATC 8951, you remember yesterday? What's the number we divide? Divide by 12, right? That's the normal. Here in the lab, you always divide by 12. Why? Our frequency here always 11.0592 divided by 12. Actually, you can skip this. You can directly write 1.085 microsecond. But we have a problem. We want 50 millisecond. We cannot divide it by microsecond. So, the 50 millisecond, you multiply by 1,000, it will become 50,000. Are you listening, everyone? Khaled, Muhayyad? Oh. Bandar? Oh. So, 50,000. Is it clear so far here? Do you understand this? Yes. Then you do the calculation. No unit, it will be 46,000. 82, you subtract it there, the answer will be 19452 with decimal places, right? Round it up. So if you round it up, it will be 19453, correct? Yes? But no problem. I will forgive you even if you use 19452 or you use 19453. Okay, because in the lab, there is -1. But in theory, the book by Mazidi, there's no -1. You see the problem? In the theory, there's no -1 in the formula. But in the lab, the one who made the book, he put -1 in the formula. Why? Maybe because he is considering 0 to 65,535. 0 to 65,535. But in theory, we consider after 65,535, you go back one more step to 0. So it will be like 65,536 steps, right? Because look, you will count from 0 to 65,535 and add one more to go back. So after 65,535, it will be 65,536, right? Plus 1, it will be 65,537. That's too much. That's why the author subtract 1. So what will we do in the lab? We use this formula. Okay? Now, the problem only when you reach 49, when you reach this number, maybe you will say round, this will be 19452. Or round up, it will be 19453. Now, why I round it up? But while in theory I said just take the whole number, right? In theory, because the answer in the book, in the slide, in the lab, for BFD. If I use 19452, the answer is 4BFC. It's not the same. But for me, I forgive you if you use 19452 or 19453. It's not really a big issue. But in the lab, we subtract 1 here. Clear? Is this clear? Now, is this hexa? This is not yet hexa. By calculator, no need to calculate, no need to do the manual way into auto. Make it mode 4. Is it mode 4? In the calculator, mode, scientific calculator, mode 4, right? Bin hex. Yeah, you have a scientific calculator, no? Then you change this for BFD. Okay? Now, look, this is another trick. The problem, some students, they are wrong where to put the L and the H. So the L will be the FD and the H will be the 4B. The higher byte, the left. The lower byte, the right. Therefore, the answer TH0 will be 4B. Be careful. This is 0, huh? Why 0? Because my question is timer 0. Now, you can also check this one. Look, I calculated 500 milliseconds. If I use 500 milliseconds, look, if I use 500 milliseconds, good, huh? By the way, how will you make the 50 milliseconds to become 1 second? How will you make 50 milliseconds to become 1,000 milli? You have to multiply 50 by, if you multiply 50 milliseconds, I multiply by 20. 1,000. Is 1,000 milliseconds 1 second?
Yes.
Yes. Therefore, the technique we will do is like this. We will call the delay 20 times. You understand?
Yeah.
So we will put like this. Delay, 20 times, huh? But that's very wrong. What's the better way so that we can repeat calling? Look, for x equals 0, x less than 20, x plus plus, and then inside the bracket, we put call the delay. See, clear? Now, look, for 500 milliseconds, we have a problem. The problem is this, when we subtract, we got negative. Because the 500 millisecond, you make it 500,000 microsecond, you divide it, you got a very big number, bigger than 65,535, you will have negative. If you got negative, you have to cancel the 500. You have to think of another number where when you subtract to 65,000, think, you're only subtracting 65. Of course, if your number bigger than 65,000, it will really be negative. And it's wrong. You cannot continue with the calculation. So what did I do? I just make it 50 again. So if I make it 50, remember if we make it 50, we got the answer.
Yes.
And what's the answer? This is the answer if we make it 50, right? For BFD, correct? Okay. Now, what I'll just do is I'll just multiply this 10 times. Correct? I will make, listen to me, this is difficult. I will make a for loop, but 0 less than 10. Can you follow? Look, my question 500. You calculate it, it becomes negative. So what's the solution? Make it 50 millisecond, you got 4 BFD again, but then you have to repeat it 10 times. So in your program, you will do something like this. For x equals 0, x less than 10, call the delay. But of course, this is not a good solution. Why? We don't need the bracket here and the bracket here, right? When do we cancel this bracket? When? When the instruction here is only one. Huh? It's like this. Oh, this is mine. You're only protecting one. Huh? Only one, you will still need to do this. Come on, that's too much. But if this is your things, you have to do this. Okay, don't come. It's good because you have more than one. But if you only have this, no need to protect too much. No need to do this. So what I'm saying, you can do like this. But don't put semicolon there. Huh? It's the same. So either you do like this or you do this. Okay? Now, why will I do less than 10? Because I cannot calculate 500. 1 second. What will you do? You will put here 1 second. What's 1 second in millisecond? 1,000. You're right, you're right. 1 second, 1,000 millisecond, right? Okay. What is it in microsecond? Oh, 1 second, 1,000 milli. How about micro? 1 million. Ah, so if I subtract 1 million here, do you think the answer will be negative? 65,000 minus 1 million. Negative. You understand? Can we calculate the THTL? No. So what's the easy way? The easy way, use 50. Remember the 50 millisecond? What's the final answer? 4 BFD, right? But we have a problem. How will we make 50 to become 1,000? Multiply by 2. It will be 50 multiplied by 2, 100. Multiply by 20, it will be, well, that's what you will do today in the lab. You will make a loop, less than 20 and call the delay. Also, be careful. This is T1 because I asked timer 1. What if I ask you timer 0? T0. This is M1 because it's mode 1. What if I ask you mode 0? M0. Let's say, listen, I cannot show you, but let's say I ask you mode 0. You will put 2 to the 16? What will you put? And 2 to the 13 is only 8,192. Therefore, we cannot use 50,000 anymore. We have to think of another number smaller than 50,000. It can be 5,000 only. 5,000 you can subtract from 8,000. Okay, let's write the program to blink all 8 LEDs on relay card every 1 second. Huh? Okay, so I'm not typing. Okay, blink all 8 LEDs every 1 second. Okay, what's the command? You said P1 equals what? 0x FF. After that, oh, come on. Delay. Oh, how to write that? I will write delay? No, what? 4 x equals 0, x less than 10,000. Isn't this the normal way we do it? Oh, and then we do this again, right? Correct? 0, 0. Isn't it? Yes or no? Any question? Oh, another way. What's the other way? Shorter way. Another way. Huh? Tilde. P1. Correct? Oh, another way. What's another way? Another way, don't use this. In theory, we can use MS delay. What will you write inside the MS delay? 250? That's 250 milliseconds. I want 1 second. 10? No. That's 10 milliseconds. I want 1 second. 1,000. Very good, Bandar. 1,000. Why I put 1,000? Because 1,000 means 1,000 milliseconds. So, this is another technique, right? Can you understand or no? I can use 4. I can use MS delay. Correct? Oh. So, I can also put it here. MS delay, right? Any question? Any problem? No problem. Now, we are talking about timer delay, which is exact. So, what we do, we cancel this. We use what timer I want. Let's say timer 1, mode 1. Okay. Timer 1, mode 1 delay. That's the name I want. That's it. That's what you will do only. So, it will call the timer delay. But remember, this timer delay that we use, if it is only for 50 milliseconds, we got 4BFD, right? Is this 1 second? No. So how will you make this 1 second? For x equals 0, x less than 20, x plus plus, and then put the open bracket, put this inside, put the close bracket. You understand? So, this will repeat, this will repeat, this will repeat 50 millisecond 20 times, and that will be 1,000 millisecond, because when you multiply 50 millisecond multiply by 20, the answer will be 1,000 millisecond, and 1,000 millisecond is 1 second. Do you understand? That's it. That's the idea. Make the P1 grid is in timer. Isn't this? But you have to also put it here. But we can also use the, if we put this here, if you put this here, you have to put it here. You put it here also. You understand the technique? Now, it looks long, so what I suggest, you can cancel the bracket. You understand what I mean? You can cancel the bracket so that it will not be so long. But you know that the timer delay will be repeated 20 times. Another suggestion, maybe we don't need to put the FF and the, you know what I mean, the FF, and instead we use tilde. Oh, this is better. This is the best solution, right?